Okay, for this, these still go with your notes, so fill these in as we go through them, but we're going to look at some speed word problems. So for number 1, if Steve throws a football 80 meters in 20 seconds, what is the average speed for the football? So I like to provide this guess chart. It helps you to organize your thoughts, to help you solve the word problems correctly. So givens, things that the problem tells you. So we know 80 meters, we know 20 seconds. Well, hopefully you're thinking, oh, distance. Distance is the 80 meters. And of course, time will be the 20 seconds. So make sure you're labeling what you're given to. D equals, distance is equal to the 80 meters. Time, T equals 20 seconds. Unknown, we are looking for the average speed. So speed is what we're looking for. From your notes, you should be able to tell me that the equation for speed is distance divided by time. All right, now you substitute or you plug in. So we have speed is equal to distance, our 80 meters, divided by our time, 20 seconds. So when you solve this, 80 divided by 20 is 4. And our units, we still have meters over seconds, so meters per second. Remember, for speed, we are doing m/s, meters per second. Number 2, if it takes Ashley 7 seconds to run from the batter's box to first base at an average speed of 4 meters per second, what is the distance she covers in that time? So for this one, we are given 7 seconds. We are given 4 meters per second. So time is going to be our 7 seconds, and it tells us that the average speed of 4 meters per second. So our speed is 4 meters per second. Unknown, what is the distance? We are solving for distance at this one. So again, you should be able to look at your notes, and you should have a triangle that looks just like this. So if we are solving for distance, we are doing time times speed. So distance is our time times speed. So we're multiplying. So we have distance is equal to 7 seconds. I like to put it in parentheses. 4 meters per second. So 7 times 4 is 28 meters. I'm running out of room over here, but 28 meters goes here. This is your final answer. So she apparently travels 28 meters. I'm not sure how accurate that is, but based on our calculations, that's how far she runs. Number 3, Bart ran 600 meters from the cops at an average speed of 5 meters per second before he got caught. How long did he run? So we are given 600 meters and 5 meters per second. Well, we should be thinking that distance is our 600 meters, and our average speed this time is 5 meters per second. Our unknown, we're looking for how long. So of course this goes with time. So we're solving for time. Again, looking at your triangle from your notes, you're covering up T. You're saying, oh, it's D over S. So that tells us that we're doing our distance divided by our speed. So now we substitute. T is equal to 600 meters divided by 5 meters per second. When you do this, you should get your answer to be 120 seconds. Time is in seconds. All right, here's another problem that you could be asked to solve. So we have a person that walks 4 meters east. So that's our first motion that we have. So that tells us that we are starting right here. So we're starting here and we're walking the 4 meters east. Then we walk the 2 meters south, 4 meters west, and finally 2 meters north. So we also end here. So we start and end at this point. So we're walking in a big rectangle. The entire motion lasted for 24 seconds. So we are determining the distance and the average speed. So for this one, distance, we know that we add everything up. So you should have 4 meters plus 2 meters plus 4 meters plus 2 meters. So 4 plus 2 is 6, plus another 6. So that tells us that our distance will be 12 meters. So this is our distance. Remember, always positive. Does not include a direction. Add everything up. All right, now that we have our distance, we can find our speed because we know that distance is divided by the time. So our distance we just found is 12 meters, And our time is 24 seconds. I know that because remember it told us up at the top. So 12 divided by 24 is 0.5 or a half. And again, speed, meters per second. All right, continuing this one again, but it changes a little bit. The only thing that we're changing is what it's asking. Determine the displacement and the average velocity. So remember, we started here and we ended here. So we can't measure this displacement. There is no displacement because we have started and ended in the same spot. So for this one, our displacement or our change in position is 0 meters. Velocity, we know is our change in position or displacement divided by our time. Well, if our displacement is 0 meters divided by our time of 24 seconds, that's going to give us 0 meters per second. So this would be another example where, yes, you moved, you had motion, but you started and ended in the same spot. So technically there is no displacement and there is no velocity, so 0 for both.